that if I had two numbers, z1 is equal to r1 times cosine of x plus I sine of x, and I had z2 equal to r2 times cosine of y plus I sine of y. All right, so I am going to multiply these. I'm going to do z1 times z2, okay, which means that I'm going to take this whole thing, r1 times cosine of x plus I sine of x, and I'm going to multiply it by r2 times a cosine of y plus I sine of y. All right, ideas. Our goal is to try and simplify it down. So ideas, what do you think?
Whole lot of factoring.
Okay.
And then hope things cancel out.
All right, so what do you want to factor or?
Because the to cosine x, have cosine squared xy, and then I know I times sine, I sine x times I sine y, the i's would turn it into negative.
So how are you getting all this that you're coming up with? What are you doing?
Foiling.
All right, so idea that, simplifying it down, we have to basically take our two parentheses here and we have to FOIL them. Okay, so that way everybody can follow along with what you're doing in your head. Okay, so which means I can do R1 times R2. Okay, so I can push those out in front. Okay, now I do what he was trying to explain. We're going to FOIL. Okay, so therefore cosine of x is going to multiply by cosine of y. First terms multiply of each other. Okay, then I'm going to do the outside terms. Okay, so plus cosine of x times I sine y. Now I'm going to do the inside terms, which is cosine of y, I sine x. Then I'm going to do the last terms, I times I, so therefore I have I squared, and then sine x and sine y. Okay, so it kind of got a little jumbled here at the end, so that's I squared sine x sine y. All right, ideas, what can we do?
The last I turns negative.
All right, the I squared changes into a negative. All right, now what do you see? All right, Ryder?
Cosine squared xy minus sine squared.
All right, that's not cosine squared, because that's cosine of x, cosine of y. And so you can't say cosine squared. Remember, order of operations, you would figure out the cosine value first and multiply by a new cosine value. Yeah.
You can combine the like terms.
Okay. Which ones are like terms? Which ones can we combine together?
Like cosine.
Because I see a cosine x, cosine y, but I don't see another cosine x, cosine y to combine it. So I don't see any like terms, but there's a little thing that I had you take out of your folders that I said you should be looking at. What do you see?
Is it the equivalent of multiplying the addition, cosine, addition, sine?
All right, so we have the sum formula for cosine. What's the sum formula for cosine?
Cosine x times cosine y minus sine x sine y.
So don't I have cosine x, cosine y minus sine x, sine y right there? So therefore, this becomes R1 times R2 times the cosine of the sum formula of x plus y. Plus, well, what about these middle ones? What are these middle ones the same thing as? Look on that little half sheet. Where do you see it? What is it?
It's the sine.
It's the sine. So it's sine of x plus y. Okay? Yes?
Where did the I go?
Oh, and I forgot about the I, so thank you. So let's just put the I right there. Okay? All right, so basically Lauren caught it. We factored out the i's here, and that's why the i's out in front. And then cosine x sine y, cosine y sine x is the same thing as some formula for sine. Yeah.
Where did the negative come from?
What's I squared equal to?
Oh,
-1, so that's where the negative came from.
Wait a minute. If this is negative, then why is this positive?
So all right, so look on your formula sheet. Do you have your little half sheet out?
That one?
Yep. Look right here. Doesn't that say minus? Yeah.
Could you say could you factor that down even more and say it's R?
No, we're just gonna leave it like that, okay? All right, so big idea, and we're gonna practice with this, okay? You basically just have to multiply the two numbers in front, add the angles together, and then from there it's using the unit circle, okay? So as an example, okay? R1 is 8, R2 is 4, 8 times 4 is 32. That's going to multiply by the cosine of the sum of 5 pi over 3 and 2 pi over 3. What's 5 pi over 3 plus 2 pi over 3? 7 pi over 3, and then plus I sine of 7 pi over 3 over here. Okay, and then from there, I go to my unit circle. What's 7 pi over 3 the same thing as? What's 7 pi over 3 the same thing as? Pi over 3. So this is the same thing as cosine of pi over 3 plus I sine of pi over 3. Remember that 2 pi, in terms of thirds, would be 6 pi over 3. So we're going 1 pi over 3 beyond 2 pi. So we're doing a circle and then some. That gets us into the first quadrant, which is pi over 3. All right, so now all you got to do is change our values. So what is cosine of pi over 3? 1/2, I heard. Okay, and then what is sine of pi over 3? √3 over 2. All right, distribute the 32s. Half of 32 is 16. And then plus, you can have 16i root 2. You can have 16 root 2i. You can, whatever you want to do for...
Do you mean
Yep.
3?
Sorry, root 3. Yes, you're right. Thank you. Root 3. Yes?
How did you get from 7 pi over 3 to 2 pi over 3? Like, how did you...
2 pi over 3? Okay, so in terms of our unit circle, okay? So if I were to kind of graph it out. Would you agree that this is 3 pi over 3? 6 pi over 3? 7 pi over 3 is 1 pi over 3 into another circle. So if you just subtract 2 pi, you get 1 pi over 3. Okay? Yeah, however you want to look at it. I kind of look at it visually this way in terms of I'm doing more than one circle. Okay? All right. See if you can do example 2 on your own. Several people have been asking, how come we didn't FOIL these numbers out? Okay, why didn't we FOIL this? Okay, the whole reason of what I tried to show you up here is how it works with any numbers. That's why we start out by using variables. Okay, which means that we can go directly to what I have here in the box. And then that way it saves you the step of having to FOIL. You don't want to have to do that. It's a whole lot easier understanding that, oh, all I have to do is multiply the r's and add the angles. That's all I got to do. Okay, and then from there, go to my unit circle. Okay, so that's why down here, I can just go directly to 3 times 5 is 15, and then go to cosine of 5 pi over 4 plus pi over 12 is 16 pi over 12, which I'll simplify down to 4 pi over 3, and then plus I sine of 16 pi over 12. Otherwise, I would have to FOIL it, but that'd be a lot of work, okay? Everybody good with that? All right, so then to simplify it for you for the division, okay? I'm going to first give it to you in general form, okay? And then what we'll do is we'll apply it. Okay, so the only difference between multiplying and dividing,
Wait, excuse me, what about example 2?
here, I already have the answer up there. All you gotta do is distribute and you're done, and that, those should both be negative. You should have had 4 pi over 3 and 4 pi over 3. All right, so I am now gonna take R1 and divide by R2. Instead of multiplying them, now I'm dividing them. And then I am going to take my 2 angles and I am going to subtract them instead of adding them. And I'm going to do the same thing for the sine. So that's the only difference between multiplying and dividing. Now you divide the numbers, your r's, and then you subtract. Simple way to kind of help you think about it is if you remember like properties of exponents, when you divide, you subtract. Okay? All right, so if I apply it to example 3 then, I'm going to start out with 10 divided by 5. I am then going to do the cosine of 7 pi over 4 minus 3 pi over 4. And it should be plus I sine of the same thing, 7 pi over 4 minus 3 pi over 4. All right, what is 10 divided by 5? 2, done. What's 7 pi over 4 minus 3 pi over 4? 4 pi over 4, which is the same thing as just pi. So now I've got cosine of pi, and then plus I sine of pi. All right, what's cosine of pi? -1. So now I got 2 times -1 plus, what's sine of pi? 0. Okay, so now if I distribute, I get just plain old -2, and there's no I part, there's no imaginary part to this. Okay, it's still in a complex number. Okay, if I were to graph this on the imaginary or complex plane, it would be at 0, -2. Questions?
I have a question about that. If I put the I on cosine, would that just mean the graph would have?
Well, you're not going to put the I on the cosine.
Right, no you wouldn't because it's on the y, but if you did, would that mean like the x?
Well, that
axis
means,
would
all
be
right, do you
negative?
understand that the I-axis is the Y-axis?
Right,
So you're changing your Y-axis to an X-axis.
is that even possible or not?
No, we're not going to do that.
Okay.
Okay? Yep.
Wouldn't it be -2, 0? Because isn't the real number your x value?
Well, yeah, I mean, if you want to write plus 0i, you can.
Okay.
But I was, you don't have to write plus 0i. All right? Everybody good? Okay, so same thing. Okay, I'm going to simplify, our squaring. Okay? If I take, say, r squared, okay, and that is, sorry, let me back up. Let's do this. Okay, so let's say that z is equal to r times a cosine of theta, okay, plus I sine of theta, okay? And if I said, all right, find z squared. Well, what I'm going to end up doing is I am going to take this and I'm going to multiply it by itself. So since we just did multiplying, what would that mean if you take something and multiply it by itself? Use the multiplication formula. What would you do? So you would end up with an r squared because the r would multiply by r. And then you would have cosine of what? 2 theta because it would be theta plus theta, or 2 theta. And then the same thing plus I sine theta, or 2 theta. Okay? So there you go. All right, and that is all based upon the multiplication one from before. I just didn't write it all out.
So would you suggest that we solve for the original one and then just multiply it by 2 all the way down?
So what's going to happen here, as an example? Let's say, z was equal to 2 and then cosine of pi and plus I sine pi. Okay? So what you would do is you would square the 2 and get 4. You would change pi into 2 pi, and you would change pi into 2 pi, and then you would evaluate using your unit circle.
All right, thank you.
Okay?
Wait, so wouldn't the I squared just be regular I?
It would not be I squared, okay? And the reason is going back to our multiplication 1. Remember that when we FOILed it all out, the I squared became a negative 1, which helped us create the sum formula for cosine. Okay? And that's also why it's not a 2i, it's just plain old I. Okay? All right, so then if I were to up the game and say, all right, well, what if I had z to the nth power? Because as you see here, we're going to do a fifth power here. Well, then that would equal a r to the fifth power, and then cosine, or sorry, I shouldn't use fifth power, I meant nth power. R to the nth power, and then cosine of n times theta, plus I sine of n times theta. Okay, make sure you see that that's not a misspelling. I didn't spell sine with two n's. You take whatever your exponent is and you're going to multiply it by your theta. All right, so this one we are going to apply to example number 4. Okay, but what's the difference with example number 4 compared to our other examples? It's not in the right form. Okay, so right now it's in complex form. We have to change it into trigonometric form. Okay, reason why I put this on here is to review how to do that. How can we change it from this form into trigonometric form? It's what we just went over on the homework.
Change it excluding the exponent and then do the exponent.
Okay, so we're only going to focus, so our complex number is this, without the exponent. Yes, so we're not going to use the 5 for right now. We're going to use that in a second. Okay, I want to know, what does z equal in trigonometric form? And remember, that means I want r cosine theta, okay, plus I sine theta. That's what I want this to change into. All right, well, if I'm going to do that, I need to know what r is. How do I get r?
R squared.
Go ahead.
R equals the square root of a squared plus b.
All right, so r is equal to the square root of a squared plus b squared. In our case, that would be the square root of
Negative root 2 squared.
negative. Very good. Okay, so what is the square root of negative root 2 squared plus root 2 squared? Just 2. Okay, because you're going to get a 2 plus a 2 inside the radical, which is going to add up to be 4, and the square root of 4 is going to be 2. All right, the other thing I'm going to need is my theta value. So how do I get theta? Okay, so tan theta is equal to b over a. In our case, it would be equal to root 2 over negative root 2, which is equal to negative 1. When is theta equal to negative 1? There are two possibilities.
3 pi over 4.
3 pi over 4 is one of them. What's the other one? 7 pi over 4. All right. Which one are we going to use? Why the 3 pi over 4 and not the 7 pi over 4? What quadrant is this in? Second quadrant. Which of these angles is in the second quadrant? So that's why we're using this and not this. Okay? So remember, you have to make that correlation. All right? So what this means is we are now taking a value of 2 times cosine of 3 pi over 4 plus I sine of 3 pi over 4 and raising it to a power of 5. All right. What that means is the very first thing I do is my r to the 5th power. So what is 2 to the 5th? 32. Okay. Next, I take my exponent and I multiply it by each of the angles. Okay. So therefore, I have cosine of 15 pi over 4 plus I sine of 15 pi over 4. Now, 15 pi over 4, remember, is more than one full circle. Because 8 pi over 4 would be 2 pi. So what is this equivalent to between 0 and 2 pi? Dan?
I don't get how you're getting 15 pi.
Oh, all right, so based upon our formula up here, notice we said to take the n value, our exponent, and multiply it by theta. So I'm taking my 5 and I am going to multiply it by 3 pi over 4. So now 5 times 3 is 15, 1 times 4 is 4. You good there? Okay, so I still need an equivalent value between 0 and 2 pi.
2 pi.
Not 2 pi, not 3. How about this? I just got done saying that, 2 pi is equal to 8 pi over 4, right? So like Lauren said, can't we just subtract 2 pi? So what's 15 pi over 4 minus 8 pi over 4? Somebody said it.
7 pi over 4.
So now it's the same thing as cosine of 7 pi over 4 plus I sine of 7 pi over 4. Remember, you got to be able to possibly, simplify some of these, because when you start multiplying, numbers or squaring or, raising them to other powers, they will get big. All right, so from here, I just need to know what cosine of 7 pi over 4 is. Looking on your unit circle. We got what? Root 2 over 2. And sine of 7 pi over 4. Hopefully you got a negative root 2 over 2. Good. Okay, and so the last thing I just simply have to do is distribute the 32. Okay, and so 32 divided by 2 is 16, so I got 16 root 2. 32 divided by 2 again gives me a minus 16I root 2. Okay? So you're using your unit circle quite a bit. So please be careful with that. All right?